Good morning, dear students. My name is Ferhan Mazher, and today we are studying the subject of Cambridge O Levels Physics 5054. And today we are going to solve a theory paper, and we call it paper 2. And we have selected May June 2022. Uh, I means May June 2022, and it's Physics 5054 2 paper. This paper 2 belongs from the zone 2. In this video, in this session, I'm going to solve the section A of this paper. The section B of this paper I will solve in another video, which soon I will upload, and you will be able to find that video also in the same playlist. So in this video, I'm going to attempt the section A of this paper. So let's start today's paper. Here we go. So the paper is coming up on your screen. Okay, so uh, so the paper which we are going to solve is May June 2022. Paper is 2-2. We call it the theory paper. The time allowed is 1 hour 45 minutes. And today we are going to attempt the section A. Okay, it says that figure 1.1 shows a water skier pulled horizontally across the water surface. The mass of the water skier is 60 kg. The gravitational field strength G is 10 Newton per kg. Calculate the weight of the water skier. The mass of the water skier is given, and they want you to find out the weight. The formula is W is equals to mg, where the G is the gravitational field strength, whose value is also given 10 Newton per kg. Just put those values and you will be able to find out the weight. Okay, so here we go. W is equals to mg, so 60 multiplied 10, and that will be equals to 600 Newton. 600 Newton will be the weight. Okay, the next thing they are asking is mass and weight have different units. State two other differences between the mass and the weight. You see, mass and weight, they are two different things. The mass is a scalar quantity, whereas the weight is a vector quantity. And the mass remains constant if you change the location and measure the mass will remain constant. Whereas if you change the location, and the mass of the weight of the same body will be different at different locations, and the weight depends upon the value of the gravitational field strength on that location. So if the value of the G will change, the value of the weight will also change. So the value of the weight changes with the change in the location. So mass is a scalar, weight is a vector quantity. Mass of a body remains constant on different locations. Weight of a body is different on different locations depending upon the value of the G on that location. Okay, so now we are going to the next question. A boat pulls the water skier to the right with a horizontal force of 50 Newton. The water skier travels at a constant speed. Explain in terms of the horizontal forces acting why the speed is constant. You see, if he is being pulled towards the right with a force of 50 Newton, but he's going with a constant speed, that means that the resultant force acting on him is zero. Acceleration is zero. The resultant force is zero because the forces to the right and the forces acting towards the left, they are equal in magnitude and opposite in direction. That's why the resultant force is zero. So the forces to the left will be the frictional forces. There are two frictional forces, main two frictional forces. One frictional force is the air resistance, which is acting opposite to his motion, and the other frictional force will be the friction between his board and the water. So, so the frictional forces which are acting to the left side, they are equals to the force which is moving him, which is to the right. So the resultant force is zero. That's why he's moving with a constant speed. So let me show you my answer. So my answer is force to the right is balanced by the air resistance and friction between skis and water. And then they say the horizontal forces acting to the right increases from 50 Newton to 70 Newton. The size of any other forces are unchanged. Calculate the acceleration of the water sphere. Now you have changed the forces acting to the right. You have made it 70, but the forces acting to the left, they are still 50. So the resultant force will be 70 minus 50, and that will be 20 Newton towards the right. According to the Newton's second law of motion, F is equals to ma, where F is um, the resultant force. The mass of the sphere is 60 kg. So I can find the acceleration. F equals to ma is the formula which I will be using. So you can see the resultant force is the force to the right minus force to the left. The force to the right is now 70 Newton and the force to the left is 50 Newton. So when you subtract them, 20 Newton force will be the resultant force and it will be towards the right. According to Newton's second law, F is equals to ma. So A will be equals to F divided by m. And F is 20 Newton and m is 60 kg. So you will get 0.33. So the acceleration is 0.33 meter per second square. So my dear students, question number 1 is completed. So let's have a look at the marking scheme. So the marking scheme is showing up on your screen. I have already checked these answers with the marking scheme. And what you can do, you can increase you can, let me reduce the size so you can see the marks also. So the question number 1 marking scheme is showing up on your screen. You can pause the video and you can take your time with this marking scheme. Okay, so we are going to the next question. Figure 2.1 shows a long cardboard tube sealed at both ends, which contains many small pieces of a metal. Okay, the tube is turned vertically so that the pieces of metal falls from one end to the other. The temperature of the pieces increases as a result of the fall. During the fall, the gravitational potential energy of the metal pieces is transferred to other forms of the energy. States two forms of energy to which the gravitational potential energy is transferred. When you flip it, uh, the metal balls will fall downward, and so your gravitational potential energy will convert into the kinetic energy. It will also, because they are colliding with each other and they will collide with the bottom of the tube. So the thermal energy is also produced. Some sound energy will also produce. So let me show you my answer. So the gravitational potential energy is transferred into the kinetic energy and thermal energy. With it, some sound energy is also produced. Some sound will also come. So then the next question is that pieces fall an average distance of 1.2 meter during one turn. The total mass of the metal pieces is 150 gram. Calculate the loss in the gravitational potential energy of the pieces as they fall once. The gravitational field strength G is 10 newtons per kg. You see, the loss in the gravitational potential energy, the formula for that is mgh, mgh, where m is the mass in kg, and the g is the gravitational field strength, and h is the height from which the body falls. So just put those values in that formula and you will be able to find the loss in the gravitational potential energy. The loss in the gravitational potential energy is mgh, 150 gram, but we don't take the mass in grams in this formula, we take the mass in kg. So for that purpose, I will divide it with 1000. So 150 divided by 1000, multiply 10, multiply 1.2. 1.2 is the height from which they fall, and 10 is the gravitational field strength. And so your answer will be 1.8 joules. 1.8 joules. So that's the first part of the B. The next thing is the student turns the tube quickly after the small metal pieces have fallen from one end to the other end 80 times. Their temperature has increased by 7 degrees centigrade. Determine the specific heat capacity of the metal. Okay, so you have turned it 80 times. So when you turn it one time, the energy produced is 1.8 gram. So 1.8 joule, sorry, I said gram. 1.8 joules. So you multiply the 1.8 with 80 because you did it 80 times. So the total heat produced will be 144 joules. You know, when the temperature changes, the formula is heat is equals to mc delta theta. So m is the mass and c is the specific heat capacity, and delta theta means the change in the temperature. So m heat is equals to mc delta theta. So heat is 144 joules, and the mass is 150 grams, and the specific heat capacity is question. The change in the temperature is 7 degrees centigrade. So the small c will be equals to 144 divided by 150 divided by 7 equals to, and that will be 0.137 joules per gram per degree centigrade. So when you round it off to two significant figures, it will be 0.14 joules per gram per degree centigrade. So I hope you understand this numerical. It's a 3 marks numerical. And let's go to the next part. That's the 1 mark question. The student repeats the experiment, turning the tube more slowly. Suggest why are different temperature increases obtained. When you do it slowly, the same amount of heat is produced, but in a larger time, in a larger duration. The time lapse will be larger. So the tube will have enough time to lose the heat to the surrounding. So the rise in the temperature of the metal or the tube will become less, because the tube will get enough time to cool down by losing its heat to the surrounding. So let's see what I have written. My answer is more time for the heat produced to be lost to the surrounding. So that is the question number 2. We are done with this. Let's have a look at the marking scheme. I have already checked my answers with the marking scheme. So my dear students, the marking scheme of the question number 2 is showing up on your screen. So our answers are right. So let me check. 140. They gave the answer in 140 joules per kg per degree centigrade. I took joules per gram per degree centigrade. So both the answers are right. Okay. So this is the marking scheme of the question number um, 2. If you find this different from the answer which we gave, the reason is very simple. Our units are joules per gram per degree centigrade. Okay, their units, the answer is kg. So the next question, it says figure 3.1 shows a syringe mounted vertically in a block of wood and sealed at one end. A plunger is free to move inside the syringe. There is trapped air in the syringe. So here we have trapped air. This is the plunger. This is the syringe. It is sealed here. Okay. The air inside the syringe exerts a pressure on the walls of the syringe. Define the term pressure. That the pressure is very simple. The pressure is the force per unit area. The force acting per unit area, that is called the pressure. It's a 1 mark question. So the force exerted per unit area is called pressure. Okay, and the next one is explain how the air molecules in the cylinder of the syringe create a pressure. You see the air, its molecules are moving randomly, and during their random motion, what happens? They collide with the walls of the syringe. So when they collide with the walls of the syringe, they exert force on the walls of the syringe. So that force on per unit area of the syringe, that is the pressure. So let me show you my answer. Air molecules are moving randomly in cylinder, or you can say syringe. During this, they collide with the walls of the cylinder. In the place of the cylinder, you can choose the word syringe. During collision, they exert force on the walls. This force per unit area is called pressure. Okay, so we are going to the next question. He says, a 10 Newton weight is placed on top of the plunger. The plunger moves down slowly so that the temperature of the air inside the syringe does not change. Before the weight is placed on top of the plunger, the pressure of the air inside the syringe is 1 expo 5 Pascal. The volume of the air is 50 centimeter cube. The cross-sectional area of the plunger is 1.2 into expo minus 4 meters square. I calculate the pressure of the air in the syringe after the plunger stops moving. Okay, so I know the volume V1, I know the pressure one, I know the V1, and they want me to find out the, you know, the pressure too, means when the you have added 10 Newton weight. If you know the pressure and you know the volume and the cross, so you know the cross-sectional area and you know the pressure, so you can find how much the force was acting on that plunger. So the force will be equal to the pressure multiply the cross-sectional area. So you will get the force, then add 10 Newton in that force, and then find the pressure too. Okay. The cross-sectional area still will be the same, so we can find it. It's a little heavy question. You see, the pressure one will be equals to the force one will be equals to the pressure one multiply with the area, the cross-sectional area. The pressure one is 1 expo 5 Pascal. The cross-sectional area is 1.2 expo minus 4 meter square. So just multiply them on the calculator, you will get 12 Newton. So that's the force which was acting. So the F2 will be F1 plus the weight you added. That will be 12 Newton plus the 10 Newton. That will become 22 Newton. Now the pressure 2 will be equals to the force 2 divided by the cross-sectional area still will be the same. So the F2 divided by the area, and you will have 22 divided by 1.2 expo minus 4, and you will get 1.8 expo 5 Pascal. 1.8 expo 5 Pascal will be the pressure 2. This question is a bit unusual. So I hope you understand this. And let me show you question number 3. So 1.8 expo 5 Pascal is the right answer, sir. Okay, so we are going to the next question. It says, calculate the volume of the air inside the syringe after the plunger stops moving because the temperature has not changed. So we can apply that Boyle's law that says P1 V1 equals to P2 V2 because the temperature has not changed of the gas of the air. So I can apply P1 V1 is equals to P2 V2. The pressure one is 1 expo 5. The volume one is 50 centimeter cube. The pressure two is 1.8 expo 5 Pascal. V2 is the question. So the V2 will be equals to 1 expo 5 multiply 50 divided by 1.8 expo 5 equals to, and that will be 27.7 centimeter cube. If I will round it off to two significant figures, it will be 28 centimeter cube. 28 centimeter cube, and our answer is right. I hope you can see the marking scheme. Our answer of the numerical is right. Okay, so we are going to the next question, and the question number 3 is completed. My dear students, the marking scheme for the question number 3 is showing up on your screen. You can pause the video and you can take your time with this marking scheme. Okay, so we are going to the next question. The next question is figure 4.1 shows a ray of white light incident on a glass prism. Refraction causes the white light to separate into different colors. Okay, so this is red, violet, and Q and P. Okay, you remember that code word? Ronald McDonald is very ugly except Gary. Ronald McDonald is very ugly except Gary. That means radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. The visible light is further divided into 7 colors, and their order from top to bottom is Roy G. Biv. Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. So their question is define the term angle of refraction. The angle of refraction is the angle between the refracted ray and the normal. Okay. So here we go. It says angle between the normal and the refracted ray is called the angle of refraction. The next question they are asking us is The angle of incidence of the white light as it enters the prism is 40 degree, and the angle of the refraction for the red light is 25 degree. Calculate the refractive index of the glass for the red light. Show your working. Okay, so the refractive index formula is n equals to sine I divided by sine R. Okay, so n is equals to sine I by sine R. So n will be equals to sine 40 divided by sine 25. And when you enter this in your calculator, sine 40 divided by sine 25 equals to, and that will be 1.52. So when you round it off to two significant figures, it will be 1.5. So the refractive index is 1.5. It's a ratio. It does not have a unit with it. So I hope you understand. That is question number 4, and we are done with this numerical. So it will be 1.5. Our answer is right. Okay, so the next question they are asking is, using the figure 4.1, state and explain how the refractive index for the red light differs from the index of the violet light. You see, if you look at this, the violet light has bended more as compared to the red light. So that shows that the refractive index of the violet light is larger than the refractive index of the of the red. So because he used the word calculate, he said compare the explain how the refractive index of the red light differs from the refractive index for the violet light. The words he used. So you will state that the refractive index of the red light is smaller as compared to the refractive index for the violet light. The reason is, how do I know that? Because the red has deflected less, it has bended less as compared to the violet light. So let me show you my answer. Deflection of the violet light is more than the deflection of the red light. It means refractive index of the violet light is more than the refractive index of the red light. You can phrase it proper. I phrased it with respect to, I explained the refractive index, the violet color, but you can also write it, which will be the right answer, that the red light, the refractive index for the red light will be less than the refractive index of the for the violet light. The reason is because the red has deflected less. Both ways, the answer is right. Okay. So we are going to the next part, and he says, the source of the white light used in the figure 4.1 produces other types of electromagnetic radiations as well as visible light. State the name of the visible radiation found at P and the visible radiation found at the Q. So we are talking about this P and the Q. From above the red, you will have, the electromagnetic spectrum. You remember the code for the electromagnetic spectrum. It is Ronald McDonald is very ugly except Gary. Radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays. So above the visible light, the visible light is red, orange, yellow, green, blue, indigo, violet. So above the red, you have infrared, and below the violet, you have ultraviolet. So you should remember this code word. Ronald McDonald is very ugly, except Gary. So that's how we remember these names. So above the red, you have infrared, and below the violet color, you have ultraviolet. These are the waves of the electromagnetic spectrum. So we are done with the question number 4. The marking scheme of the question number 4 is showing up on your screen. You can pause the video and you can take your time with this marking scheme. Checking the marking scheme is a very, very, very important thing. Sometimes people say that, why you check marking? It's very important to check what the camera says. Okay. So a student connects a battery, thermistor, and a resistor Y in parallel as shown in the figure 5.1. So this is a battery, this is a thermistor, and this is a fixed resistor. The current flowing through the thermistor is I. The electromotive force EMF of the battery is E, And he says the current in the X thermistor is I. The resistance of the Y is greater than the resistance of the X. Its resistance is higher. Tick 2, he says, so their question is tick 2 boxes. One to show the correct statement about the potential difference across the Y, and the other to show the correct statement about the current in the Y. The potential difference across the Y, you see both of these, they are parallel to each other. So when the two things are parallel to each other, that's a rule of the electricity that they both will have the same potential drop. Whatever will be the potential drop in this branch, same will be the potential drop in this branch. And they both are parallel to the battery. So the potential drop in this branch will be equals to the battery voltage EMF, and the potential drop here will be also equals to the EMF. So about the potential difference is less than E, is equals to E, is greater than E, and both will be equals to E. Okay, it will be equals to E. Then the current in the Y, they have told us that the Y has a higher resistance as compared to the resistance of the thermistor. So that when the current will divide here, because in this branch the resistance is low, and in this lower branch the resistance is higher, so less amount of current will flow through the Y. So the current in the Y is less than I. So put a tick here, put a tick here. So let me show you. So these are our answers, and I hope you understand this. And let me take out the marking scheme. So our answer is right, sir. Okay, so we are going to the next question. The next question they are asking is, he says, the calculate, sorry. Okay, so this is the question. Okay. The student connects the thermistor X in series with the resistor Y and a battery of EMF 6 volt as shown in the figure 5.2. In the circuit at room temperature, the resistance of the thermistor is 600 ohm. Its resistance R1 is 600 ohm, and the current in the thermistor is 0.0020 ampere. So I know the resistance, I know the current flowing through it. Calculate the power produced in the thermistor. The formula for the electric power is P is equals to IV. So I know the current, but I don't know the voltage drop. So I can calculate the voltage drop. V is equals to IR. So I will know how much is the voltage drop here. And once I know the voltage, then I can calculate the power. The formula for the electric power is IV. So let me show you my calculation. So here we go. The voltage drop will be equals to V equals to IR. So it will be the current flowing through the resistor is thermistor is 0.0020 ampere, and its resistance is 600 ohm. So when you multiply them, you get 1.2 volt. So the power in the thermistor will be IV. So the current is 0.0020 ampere, and the voltage drop is 1.2 volt. So the power will be 2.4 expo minus 3 watt. So 2.4 expo minus 3 watt, that's a 2 marks numerical. I hope you understand. It says 0.0024. Our answer is right. We have written the answer in the standard form. Then it says calculate the resistance of the Y. I can calculate the resistance of that. Whatever is the current flowing here, same current will flow through the Y because they are connected in series with each other. The current has only one path. So 0.020 ampere is flowing here. So the same current will be here, 0.020 ampere. The EMF of the battery was 2 volt. It has used how much volt? It has used 1.2 volt. So the voltage for the Y will be 6 minus 1.2 volt. Once I know the current flowing here, I know the voltage drop on the Y, then I can calculate the resistance of the Y very simple, easily. So that calculate the resistance of the Y, the voltage drop across the Y will be the EMF minus the voltage taken by the thermistor. That will be 6 minus 1.2, and that will be 4.8 volt. And we know the current flowing through the Y also is 0.0020 ampere. So V is equals to IR, R will be equals to V divided by I. So R will be equals to 4.8 divided by 0.0020 and beta, you get to 2400 ohm. So the resistance of the Y will be 2400 ohm. I hope you understand. Let's check from the marking scheme. Our answer is right, sir. So let's go to the next part. He says, the thermistor is cool. Explain why this causes the potential difference across Y to decrease. Okay, it's a 2 marks question. You see, when you will decrease the temperature, the resistance of the thermistor will increase. When its resistance will increase, the resistance of the whole circuit will, due to this, will increase. So the current coming from the battery will decrease. Now the current flowing through the Y will decrease. Its resistance is still the same. So V equals to IR is the product of the current and the resistance, because the resistance of the Y is still the same, but the current now flowing through the Y has decreased. That's why the product of I and the R, V equals to IR, that will decrease. The voltage drop across the Y will decrease. I hope you understand this logic. Let me show you my written answer. He says the resistance of thermistor will increase as you drop the temperature. The resistance of the thermistor will increase. Resistance of the circuit will increase. Current from the battery will decrease because the V equals to IR, due to less current voltage drop across the Y will decrease. The R of the Y has not changed. The I flowing through the Y has decreased. So according to the formula, V is equals to IR. So if the R is not changed, but the I has decreased, the product V equals to IR, that will decrease. I hope you understand. That's the marking scheme of the question number 5 is showing up on your screen. And question number 5, here we go. So you can pause the video. You can check the marking scheme for the question number 5. Okay, now this is question number 5. Okay, you can see from here and here. Okay, so we are going to the next question. I hope you understand this. The figure 6.1 shows part of a toy which contains two ring-shaped permanent magnets. A plastic rod passes through the center of both magnets. And he says here we have two magnets. This is the top magnet, this is the bottom magnet. The top is north and the bottom of this magnet is south. The top magnet can move up and down freely around the plastic rod. The magnetic poles on the bottom magnet are shown in the figure 6.1. The top magnet floats in the air above the bottom magnet. On the figure 6.1, mark the poles on the top magnet and explain why it floats in the air above the bottom magnet. You see, if it's floating, it means the top magnet's bottom surface is north and the top surface is south. So this north and this north, because they are the like poles, they will be repelling each other. The force of repulsion, uh, due to this force of repulsion will be more than the weight of this top magnet. That's why the top magnet is floating. Let me show you my answer. North pole of the top magnet repels north pole of the bottom magnet. The force of repulsion is more than the weight of the top magnet. That's why it's. And remember another point, that you see this north and this north are repelling each other, but this north and this south, they are attracting each other. But the distance between this north and this north is less, and the distance between this north and this south is larger. So this force of repulsion will be more than this force of attraction. So overall, there is force of repulsion. Don't need to write that point here. Let me show you the marking scheme, question number 6. Okay. Okay. So we are done. The top magnet is replaced with a ring made of iron. Explain why the iron ring sticks to the bottom magnet. You see, if you will replace this top magnet with a ring of iron, so when the iron will be here, it will be inside the magnetic field of this bottom magnet. So due to the magnetic field of this, the iron is a magnetic material. Due to the magnetic induction, the the bottom of that iron ring will become a south pole, and the top of the iron ring will become a north pole. So that south and this north, they will attract each other. So this iron ring will stick to this bottom magnet. I hope you understand. Let me show you my written answer. Iron is magnetic material. Due to magnetic induction, bottom of the iron ring will become south pole and the top will become north pole. So the iron ring will be attracted to the bottom magnet because the north and the south, they will attract each other. They are opposite poles, they will attract each other. So let's have a look at the marking scheme. Iron is magnetized by induction. Iron, a temporary magnet. Poles produce iron by magnet. Unlike poles attract or okay. So the iron ring will be attracted to the bottom ring because the north and the south, they will be attracting. So I hope you understand and you are able to write a better answer. Okay, these answers which I write, I try to write the good answers, but my students can write a better answer. The top magnet, okay, we are done with this. Okay, so we are going to the next question. The B part, not the question, but the B part. Okay, he says, a wire carrying a current passes a right angle through a piece of paper. Figure 6.2 shows a cross and circle where the current in the wire passes into the plane of the paper. You remember the conductor is represented with the cross. Cross means that the current is going into the screen, into the page. And if you represent it with a dot, that means that the current is coming out of the screen, the current is coming out of the page. So here they have used cross. Cross means that the current is going into the screen. So we will be using on the figure 6.2, sketch 3 magnetic field lines to show the magnetic field pattern around the wire. Show the direction of the field on your sketch. It's a 2 marks question. So I will use the right hand rule. So I will take, this is my right hand, this is my right hand. Okay. So I will hold it like this. My thumb will be pointing into the screen. The curls of my finger is important. This is the right hand. I'm using the right hand grip rule for the straight conductor. The thumb here is the direction of the conventional current. The curls of my finger, they are showing me the direction of the magnetic field around that wire. So the current, this is my right hand, the current is going into the screen. Then my thumb, the curls of my finger, right hand finger, the right hand, the curls of the fingers of the right hand, they are showing me the direction of the magnetic field. So they will be from where I'm watching, it will be clockwise. So I will make three or four concentric circles, and I have made, you can see the concentric circles here, and I will put arrows to show the magnetic field. The magnetic field will be circular and it will be clockwise. And if you want to go more deep into this, the initial circles, they are closer to each other, and the next circle the distance between the circles should gradually increase as you move away from the wire. So this is how you will show it. And this is question number 3. She says, okay. So we are good. So the marking scheme of the question number 6 is on your screen, sir. You can pause the video and you can take your time with this marking scheme. Okay, so after this, we go to the section B. So my dear students, our section A has completed. So my dear students, today we have done May June 2022 paper, and in this video we have done the section A of this paper. The section B of this paper I will soon upload. Is I will do in another video, and you will find that that video in the same playlist. So I hope you have understood this paper. I hope you have learned from this video, And I hope that this video is helping you to, by just sitting at your home and just taking by playing the YouTube, you will be able to practice the past paper of the physics 5054. If you have benefited from this video, please share the link of this video onto your Facebook, onto your Twitter accounts, and onto your Instagram, because that helps me promote my channel. And thank you very much. I think that's a great blessing for me that I can be a mentor to so many people around the world through this YouTube channel. So it's a blessing for me. Thank you very much, everyone. Have a good day. God bless you all.